Hey guys, how you doing? It's Coach Scott. Let's start talking about acid-base reactions, which is a special type of double displacement or double replacement reactions. So anyway, in acid-base reactions, acids will dissociate in water and they release a proton or a hydrogen ion. Bases undergo dissociation in water and they release a hydroxide ion, OH minus. So this reaction is also known as a neutralization reaction when there are two ions, H plus and hydroxide, will combine to form water. So in this case, instead of forming a solid precipitate, the result of the neutralization reaction is to form water. All acids are capable of releasing at least one proton, H plus ion, in an aqueous solution. Some acids can provide more than one H plus ion. So all common acids have a chemical formula starting with H, such as ACl, HBr, HI, HNO3, H2SO4, AClO4, and H3PO4. Now, these are some common acids: hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid. You'll find those in batteries in cars. Phosphoric acid, acetic acid, another name for that is vinegar, and perchloric acid. These are pretty common. Notice all of them start with an H. So all bases are capable of releasing at least one hydroxide ion in an aqueous solution. Some bases can provide more than one hydroxide ion. Bases are ionic compounds with hydroxide ion as the anion. The majority of bases are derived from the first group of alkali metals and the second group of alkaline metals. So here's some examples. See, there's lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide. And notice there's two of these because these are group 2, magnesium hydroxide and calcium hydroxide. So acid-bases reactions involve the reaction of an acid and a base to form water and an ionic salt. So the hydrochloric acid and the sodium hydroxide will react, and once all that's used up, you'll have sodium chloride and water. That's all that'll be in the beaker. The ionic salts produced in the majority of acid-base reactions are water-soluble. So salts containing sodium, potassium, ammonium, and nitrates are soluble, SNAP. Some carbonates, sulfates, and phosphates are also insoluble, but we won't consider those too much. So the ions appear to switch places with each other as in a precipitation reactions. So the bond between the hydrogen and the chlorine will break down in the hydrochloric acid. Then the hydrogen will form a bond with the hydroxide that's coming from the sodium and the hydroxide that breaks. So the sodium will form a bond with chlorine. So the product NaCl is soluble in water. So the ions are doing their thing, resulting in a clear solution. So here's some examples of acid-base reactions. You've got nitric acid and potassium hydroxide will form potassium nitrate and water. Sulfuric acid and magnesium hydroxide will react. The bonds will break and new bonds will form. You'll form mag sulfate, aqueous, is still soluble, and water. These are the salts. Phosphoric acid, H3PO4, and lithium hydroxide will react and form lithium phosphate, the salt, and water. So in all of these reactions, chemical bonds break and they reform to produce the salt and the water. So here you have hydrobromic acid and calcium hydroxide. First step, write them out in the right formula. HBr plus KaCaOH2, calcium hydroxide. And the reactions are going to be what? You're going to have water and calcium bromide. And write the right formulas for the products out. Now we have to put the right phases in and balance it. So these two are aqueous. That is aqueous also. It's unique. And then you have water. So one hydroxide ion is needed for each hydroxide ion, or for each proton, for each H plus ion. So since we've got two hydroxides, from each calcium hydroxide, there are going to be two hydrobromic molecules that are required to release two protons. Will this reaction proceed? Yes, because all acid-bases reactions will occur. Let's look at one more. Predict the products of this reaction. Sulfuric acid plus sodium hydroxide. Both of those are aqueous. So predict our products. The sodium will displace the hydrogen, so you're going to have Na2SO4, then you're going to produce water. Now let's put our phases in. That's going to be aqueous, and that's going to be aqueous because of the SNAP rules. Aqueous, aqueous. So for each sulfuric acid releasing two protons, there's going to be two sodium hydroxides are required to release two hydroxide ions. Will this reaction proceed? Yes, it will, because all acid-base reactions will occur. When you have an acid and a base, it's going to happen. Okay, guys, so there's our first discussion on acids and bases. We'll go into more of it later in another unit. So anyway, this is Coach Scott saying bye for now.